All right, well, as the title suggests, we are working on site-scale restoration planning on the lower Virgin River in Nevada, just above Lake Mead. It builds on a lot of the same concepts that Glenn just talked about in terms of the eco-hydrological approach. Builds on some previous work that we did that was funded by the Walton Family Foundation that we talked about at last year's conference. The goal of this project is working with the Clark County Desert Conservation Program under their multi-species HCP to develop a restoration plan to enhance and expand habitat for the southwestern willow flycatcher and some other covered species under their HCP on an 80-acre parcel in the Mormon Mesa area. A little closer? Okay, thanks. Here's a photo of the Mormon Mesa Reach looking from the eastern edge, looking west towards the Mormon Mesa. You see this big field of defoliated tamarisk. It's probably, 95 to 99% of the vegetation is tamarisk. And this shot was taken in September. But you can see this nice emergent green canopy of the Gooding's willow poking up. And this patch right here is one of the remaining prime southwestern willow flycatcher habitat patches in the lower Virgin River system. So of obvious interest and priority for restoration planning. This project has a variety of project partners working with Clark County. They provided the primary funding. There was some supplemental funding provided by the Walton Family Foundation. We worked with the Great Basin Institute. Their crews did the tamarisk cutting and are actually out in the field right now doing the planting. Also worked with partners in conservation, and then UC Santa Barbara, Tom Dudley's research group. Here's a quick overview of the Virgin River. Our study area that we talked about last year was the whole river corridor from Zion National Park all the way down to Lake Mead, about 120 miles. But for today, I'll be focusing just on this lower part of the river, the Mormon Mesa Reach, shown by that red circle. So last year's phase 1 eco-hydrological assessment didn't have all the steps that Glenn just talked about on the Gila, but we took it through sort of initial course cut for potential restoration priority areas. As with the Gila system, the Virgin River is a very dynamic system. It's prone to episodic floods that reset the vegetation, reset the floodplain. It's dominated by tamarisk, especially in the lower river, but we also know with the presence of the leaf beetle that vegetation is undergoing a process right now of very dramatic change. And so our challenge is to project what is that restoration trajectory under the impact of the beetle, and given at least the short-term adverse impact on southwestern willow flycatcher, what can we do in the immediate near term to try to sort of jumpstart the native vegetation recovery process and provide some important habitat for southwestern willow flycatcher in particular. From the phase 1 effort, we identified potential restoration sites along the lower river. These areas shown in yellow-orange here. There were about 3,500 acres from the Virgin River Gorge all the way down to Lake Mead, and you can see a big concentration in the lower part of the river. And that just, not so coincidentally, overlaps with the primary areas that were recently occupied by southwestern willow flycatcher. If you caught Mary Ann's talk yesterday, you know that they're in dire shape on the river right now. But sort of the main area of focus and possibility of holding out the flycatcher right now is in the Mormon Mesa area. Our challenge in this system then was to build on that phase 1 eco-hydrology assessment to provide a more in-depth analysis of the Mormon Mesa Reach using NRCS soils data as well as some site-specific soil sampling, using the relative elevation as a proxy for depth of the groundwater, and using LIDAR canopy height data to get at vegetation structure, and combining that with what we know about southwestern willow flycatcher habitat in the area. So the first step of our analysis for Clark County was to do this eco-hydrological assessment at the reach and site-specific scales that included some field surveys for vegetation mapping and surface water and soil assessment. And then that information then was intended to lead into a site restoration plan that was the final product that Clark County needed to get moving on some immediate restoration. Here's a Google Earth image overview of the lower Virgin River, Mormon Mesa area. Shown in black is the outline of the county's parcel. And I'll just zip through a few shots here to give you a quick overview. Most of this vegetation you can see here in the dark green is tamarisk. There are a few patches of the emergent Gooding's willow. And just this shot was taken after the December 2010 flood, the last flood, resetting flood, that happened to carve out a chunk in the southwestern corner of the county's parcel. I'll talk about that in a few minutes. Here's the active channel, the flood reset zone, using the same methodology that Glenn talked about with historical air photo imagery for the last 3 major floods. And here's the results of our phase 1 assessment, just showing for this particular area where those potential priority restoration areas were identified. As on the Gila, that gives us a large amount of area. We need to refine that to really zero in on where can we do immediate action that really has the most likely beneficial effect for southwestern willow flycatcher. We overlaid that with the recently occupied areas. The brighter pink or magenta here were areas that were occupied in 2011. These other sites were occupied in earlier surveys but are no longer occupied. So next we moved on to the relative elevation mapping. As Glenn talked about, that this is a relative elevation of the ground surface across the floodplain. And one thing to point out here is the main channel is shown on the west side here. You can just sort of pick it up. But in this particular part of the floodplain, there's a lower, essentially a lower relative elevation flood basin with the whole channel network on the east side of the parcel. And that's going to be very important. We'll talk about that in a few minutes. We also have the LiDAR data looking at vegetation canopy height. You probably can't pick it out unless you're in the front of the room, but there are some darker green little pixels here that are picking up the 7 to 10 meter canopy of the Gooding's willow that is emerging from the tamarisk area. But we also looked at patches of tamarisk that were in sort of the above the 5 to 7 meter zone as another indication of sites that probably have high plant production potential and probably have a pretty good suitability for native plant restoration. Next, we compiled all the layers in the GIS and started delineating restoration priority polygons, similar to what Glenn talked about earlier. Green shows the higher priority areas, and then blue sort of a medium priority area. And here's a Google Earth image just to get us back to that same perspective. Once again, the county parcel here. Polygon 26, this brighter green area, is a high potential area that overlaps with the current swiffle habitat nesting area, the occupied area. So the next step is to then move on to the site restoration plan. I'll just give you a quick overview of the elements that went into that. I won't go into a lot of the details about what was in the planting mix or the densities or any of that information, but I could provide that to anyone that was interested later. And some of that is being modified right now. We were just out in the site last week working with Clark County and working with the planning crews that are out this week to make some changes. So next, we wanted to really get a better handle on the existing conditions on the site. We used existing aerial imagery combined with field surveys to just sort of ground truth our remote sensing data. Here's a recent image. This was taken from Utah State's remote sensing data from November 2011 after that big flood. The good occupied southwestern willow flycatcher habitat's right up here, just extends just slightly into the edge of the county's parcel. So the UCSB field crews did field surveys in September as soon as we had the contract in place to quickly get out there and provide some quick information we needed to give the county and the Great Basin Institute guidance before their crews were out doing their initial field work at the end of October. Here's zeroing in on the floodplain relative elevation. Once again, you can see the main channel zone here, this flood reset zone that's turning out to be a nice natural recruitment area, sort of a low backwater channel that exist next to that cut bank at the edge of the dense tamarisk zone. And then this whole network of channels in the eastern half of the site that are at low relative elevation. And using that relative elevation information along with site observations, we were able to really test our hypotheses that the surface and shallow groundwater flow was generally moving from a northwest to southeast direction across the county parcel, shown by these yellow-orange arrows. And just as a reminder, the flow path of the main channel is shown by the blue arrows over here. That's a very, very useful information. You can see sort of this core area then became a key focus for our attention for areas that really had the most potential to provide all the key habitat elements for the southwestern willow flycatcher. We then used the field observations of vegetation data plus all the remote sensing layers and geomorphic information to develop these vegetation management units that then allow us to sort of develop a phased approach to restoration planning for the whole parcel that would go beyond this current initial phase. It's really more of an emergency action to get something going for the flycatcher. One of the challenges as we look into what makes sense on this site are various logistical challenges. One is with the current funding, it's all being done manual labor for cutting. There's limited amount of native plant stock, so we really needed to pick small areas that would make the most sense. We also have this big challenge of trespass cattle in the area. So until those cattle are removed, there's this concern over what's it going to take to keep them away from the revegetation areas without spending lots and lots of money and effort fencing them out. One thing we came up with was this idea we're talking about patch clearings and replanting for the native vegetation within that dense tamarisk matrix. And one of the ideas we came up with was having the crews take the cut tamarisk debris and use it to create essentially a wall of tamarisk around the edge of each patch to supplement the more limited fencing we were doing to keep the cattle out. And it's pretty impressive. I was just out on the site last week, and some of those walls are twice as tall as me, and it's hard. I couldn't walk through them, and I think they'll keep the cattle out at least in the short term. So here's our initial planting plan. It's been modified. We made some of these changes just last week when we were out there, but the crews in October went out and provided cut paths through the tamarisk and started locating these different patches and beginning the clearing of the main patches. Site A was one we had proposed, but when the crews got out there, it looked a bit dry, so we've left that as a lower priority or not dealing with it right now. These other sites all have surface water in the area, as well as Gooding's Willow nearby or on site, and they looked like they really met our criteria for having high habitat suitability potential for flycatcher habitat, and they're adjacent to this occupied flycatcher habitat zone, Unit 5 here. So our idea is to use these small patch clearings and plantings to essentially extend that habitat patch. And then if this works, the idea is we go back and start filling this in over time, probably working our way sort of down in this direction, following the water flow path. And by doing this in phases, we're also creating a more complicated heterogeneous habitat structure that'll hopefully provide a little bit longer term habitat for the flycatcher, as well as just getting in and creating more native sources of native plant seeds and propagules to promote natural recruitment as well. Then we also have this area that was in the flood reset zone in the southwest corner of the parcel. I showed on the LiDAR, the relative elevation image. You can sort of pick it up here. There was this back channel that was created in the December 2010 flood along that flood bank that still is visible when you go out there today and has standing water as of right now. So our idea there was to, initially was just to create sort of 1 acre patches right adjacent to that backwater channel with surface water and fence out cattle to then have intense plantings of cottonwoods, Gooding's Willow, and sandbar willow. But talking with the county, they decided they had enough money to basically fence this whole area. So we're going to do the more intensive plantings here to provide flycatcher habitat, we hope. And then in this larger area, which is about 7 acres, is a natural recruitment zone. We're seeing a lot of arrowweed and screwbean mesquite coming in there now, along with salt grass and various rushes. And the idea there is to use that as an experimental zone for looking at natural recruitment processes, see what comes in there on its own, as well as a variety of experimental plantings. We were just drafting up plans last week to set up several transects going across this floodplain zone where we would do plantings of the two willows and the cottonwoods, along with maybe experimental plantings of a few other native species just to see what works out there. We'll do more intensive soil sampling for salinity and nutrients. We'll also establish some groundwater monitoring wells in this area, as well as do some of the same sorts of things up here in the patch area. Here's just an example of the largest patch, this is only about 3/10 of an acre in size, so these are relatively small patches. The total of the patches I just showed on that last slide is about 1 acre here, and then we've got about 9 acres we're dealing with down here in this initial phase of the restoration plan. So you can see the defoliated tamarisk. This shot was taken in October after the crews had done the initial clearing. You can see the wall of piled cut tamarisk here, and they left the existing Gooding's willow here, which really pop out nicely against that defoliated tamarisk matrix. Here's patch F, shot I took last Thursday. Once again, you can see defoliated tamarisk, the wall of tamarisk here to help keep the cattle out. And then right now, the site, a lot of these patches, all the patches have standing water, and some of the patches actually have flowing water. This site in particular had a small stream essentially flowing through it with about 1 cubic foot per second moving through the site. Once again, supporting all of our earlier assumptions and observations that the site should have good potential for southwestern willow flycatcher habitat. So this is patch G in that natural recruitment area down in that southwest corner of the plot. I just wanted to point out a few things. Here's that backwater channel I pointed out on the aerial imagery. You can see there's surface water here. So all of this area has a very shallow groundwater table. We'll set up the groundwater monitoring wells to test it, but from what we have observed over the last few years, it maintains a high shallow groundwater table throughout the year. You can see this area near me has a lot of rushes and some native grasses coming in, a lot of arrowweed and scattered screwbean mesquite coming up in the background. What next? So on the left shows what was done in terms of clearing the patches, creating the initial cattle exclusion areas with the wall of tamarisk. That initial work for Great Basin Institute was done under Walton Family Foundation funding. And then here's what's in progress right now, this winter and spring. As I mentioned, the crews are out there right now, so we have local sources of Fremont cottonwood, Gooding's willow, and sandbar willow. Those poles and cuttings are being planted right now. The county is also working with other partners to find other sources of native plant materials, increase the natural diversity at the site. There are a variety of other native herbaceous species and some other shrubs that are on the site just at low densities and scattered throughout. We're already seeing some of them, the yerba mansa, starting to come up in the cleared patches. So we're hoping that just with release from some competition from tamarisk, we'll see some native natural recovery as well as the intent to plant a greater diversity of mix. There'll also be a need for installing the fencing now and then moving on with weed control to deal with secondary weed invasion. There's the two big concerns on the site. In the tamarisk matrix in the patch, we mainly have perennial pepperweed that is established on the site in relatively small patches, so our concern is getting that under control quickly so it doesn't become a problem. And then in that natural recruitment area, camel thorn has come in, so that's going to be a targeted species to deal with. We also are working with the county right now to help set up and develop a good monitoring plan, as well as I mentioned, some experimental plantings and more of an adaptive management program so that they can quickly learn from this initial phase and use that to guide and develop more effective approaches for the later phases. Ultimately, they want to restore the whole 80-acre parcel. And that's it. Thank you.
My question is, it seems like that bigger fencing that that Clark County did, was in the active channel. Is that sort of outside the active channel, or how's that going to work?
Yeah, so initially our fear was that that area might be too much within the active channel zone, and that was one reason why initially we had focused just on the 2 1-acre parcels further up. But in looking with one of the things I didn't have time to go into is the reach scale assessment that Glenn was involved with in the geomorphic analysis was really to look at where we think that river is going to move, so that the main flood reset zone we think is actually going to, in the next big flood, will skip that area. The river is likely to keep cutting on the downward side and move away from that area. So there is some risk. That's why the county's not investing a lot of effort in intensive planning throughout that 7-acre natural recruitment area. But we think those 2 1-acre patches are definitely pretty safe, as well as you have the proximity to surface water for flycatchers. So that was all considered. Thanks.